Dear students, today let us discuss one very important concept, that is why Fisher projection is an eclipsed conformation. I think at this point you might have come across, or you should understand it very perfectly, that the Fisher projection formula written for a molecule is an eclipsed conformation. You cannot write staggered conformation in Fisher projection formula. Whenever you are writing any molecule in Fisher projection formula, you should understand that it is eclipsed conformation only. Okay, let's see why is it so like that. Suppose if I am taking one Fisher projection formula, let's take an isomer of tartaric acid. Suppose if I am taking COOH, COOH, OH, H, OH, right? So in this molecule, if you understand, we know that the groups on the vertical line are away from the observer. Away from the observer means they are towards the backside of the board plane, right? So if they are towards the backside of the board plane, then I can say that this molecule can be shown with a dotted line, because the groups which are away from the observer or behind the board, behind the plane, behind the screen are denoted with dotted line, and the groups which are on horizontal line are towards the observer, right? So when these groups are towards the observer, then they are the ones which are above the plane, right? So these groups can be written with thick lines like this, right? OH and H, and here also this is OH and this is H, right? Now this is what we know, it is the wedge projection formula, right now. So now in this wedge projection formula, if I am observing the molecule from this direction, understand, if I am observing the molecule from this direction, this is the front carbon, this is the rear carbon, right? And front carbon is only visible, rear carbon will not be visible, because front carbon is eclipsing the rear carbon, right? So if I am having this as the front carbon and this as the rear carbon, right? So this is the front carbon, let us assume this is having, when I am observing from this direction, COOH, it will be like a triangle, in this manner, and COOH will be towards the bottom, and these two will be towards other two corners of the regular equilateral triangle, right? Now these groups, if I write like this, this is 1, 2, 3, right? Now this is the COOH, this is the H, and this left one is what? OH. Now this front carbon is eclipsing the rear carbon, right? Rear carbon, as it is not visible, if I put it as a dot, I am writing it as a circle, right? And this rear carbon also are having towards the left side hydrogen and right side OH group, and towards the downside COOH are present. Okay, so this is the COOH present, this is the this is what this hydrogen is, and this hydrogen, when you are seeing from this direction, this hydrogen is actually eclipsing this OH group, so it will not be visible, right now. And this OH group is eclipsing this hydrogen, therefore this also will not be visible. And this front carbon is eclipsing the rear carbon, therefore this also will not be visible. And this COOH is eclipsing this COOH, therefore this also will not be visible. So only the front groups will be visible and the rear groups will not be visible. But if they are not visible and if we are leaving them just like that, we may get confused that there is no group behind. That is why just adjacent to this hydrogen, I will draw one small line and put the OH group. This is the hydrogen eclipsing this OH. Therefore, I will put it also here. This is the hydrogen which should eclipse this OH group. And this is the OH group which should eclipse this hydrogen. So, just behind this OH, I will put hydrogen also, right? This is what the eclipse conformation you can see. An eclipsed form is the one in which a torsional angle, this angle, torsional angle or dihedral angle will be 0 degrees. And as different groups are eclipsing here, like COOH eclipsing, but OH is getting eclipsed by hydrogen, and here OH is eclipsing hydrogen. Therefore, as different groups are eclipsing, we call it as partially eclipsed conformation. If similar groups are eclipsing, then it will be called as fully eclipsed or completely eclipsed conformation. Hope you have understood why Fischer projection is an eclipsed conformation, right? Thank you and subscribe please.